Good day, class. After we discuss lessons regarding equilibrium, systems, bodies in equilibrium, um, we have not considered yet certain forces, which is also important when we analyze equilibrium of bodies or of systems. And that involves what you call friction or dry friction. Okay, so the concept of friction, okay, started on the concept of two different bodies that have contact with one another. Okay, so say for example, we have this object and we have this another object, so that if the two have contact with one another, okay, this is their plane of contact, the whole area wherein they are in contact with one another, so that if there is movement on each other, then there is friction developed on their plane of contact. Okay, so that the force that is developed due to friction is what you call friction force. Now, again, dry friction or friction refers to the friction force that exists between two unlubricated solid surfaces. Okay, so to continue explaining the principle, say for example, we have two objects. Okay, of course, let's say we have one isolated object and it is in contact with a fixed surface. So we are just like merely putting on this object on a surface, on a certain fixed surface, or let's say on a floor or on a table, for example. Okay, now every time two systems or two bodies are in contact with one another, there are two forces developed on their plane of contact. So when you say plane of contact, okay, it's the whole area wherein both the two systems are in contact with one another. So the area right here is what you call the plane of contact between these two objects. This isolated object and this fixed surface. Okay, so the two forces developed on their plane of contact is what you call the normal force, okay, and the friction force. So we use symbol FF to represent the friction force. Now, friction force is always parallel to the plane of contact. Normal force is always perpendicular to the plane of contact. Okay, now, friction force only exists if surface, if it is stated that surface is rough or if it is not frictionless. Okay, or if it says that it is not smooth. Okay, but if it's frictionless, if the surface is smooth or the plane of contact is smooth, then friction force does not exist, only normal force. Now basically, with the two objects, if you are going to separate the two bodies, the object and the fixed surface, when we are going to consider the FBD of this object, the normal force, now this is considered as the plane of contact right here. So that normal force acts perpendicular to that plane of contact, and always the plane of contact is towards that object. So we have this normal force. And then if this object will move, has the possibility to move, let's say for example to the right, friction force always opposes that possible motion. Okay, so if we are now going to consider the fixed surface, okay, so let's say this is the fixed surface. Now the normal force acts perpendicular, always perpendicular to the plane of contact, and friction force, if this object moves to this side, then friction force against the fixed surface is to the right. So as you see, in between the plane of contact, there is balance between normal force and friction force. So that normal force and friction force, as in the FBD of this object, normal force is upward and friction force is to the left. Assuming that the motion is of this direction. Now, when we are going to consider the fixed surface, another body wherein this object is in contact with, normal force is now of opposite direction, so that normal force here is now downward and friction force is now to the right. Okay, so that every time that the plane of contact is rough, or we actually have what you call coefficient of friction. If this coefficient of friction is not equal to 0, then friction force exists. Okay, so now with bodies in contact with one another, and aside from their contact with one another, if there is an external force applied to that system, say for example, we have force P that will try to push this object to the right. So what is developed on this object, okay, are the forces, aside from its weight, is the force acted on it, the normal force towards it, which is always perpendicular to the plane of contact or area of contact, and the frictional force, which always opposes the possible movement due to the applied external force on the object. Okay, now, whenever there is friction force involved, there will be three cases that we have to consider. First is the static case. When you say static case, it means that there is no relative motion between two surfaces that are in contact. And then the normal force N and the friction force F satisfy the following relationship. Now, this is the relationship. If the actual frictional force in a certain scenario or in a certain body of or systems is less than or equal to the maximum Fmax is what you call maximum static friction that can exist between contacting surfaces. Okay, and Fmax is equal to mu s. Okay, no, mu, this is how you read this symbol, mu sub s times n, or normal force. Okay, coefficient of static friction or coefficient of friction depends on the roughness of the surface. So the higher the mu, the more rough the surface is, or the contacting surface is. So again, now, if on a certain magnitude, okay, this is on the certain magnitude of P is where the movement or the case of this system depends on. So there is a possibility that if P is not that high of a magnitude, then this will not move, because friction force that is acting on the plane of on the contacting surface is enough to resist the movement. Kasi 'di ba, lalo na if rough ang surface, for example, this calculator, if I am going to push it forward, I can apply a certain magnitude where it can't move. Okay? It is because of the roughness of this paper. So there is a friction force that is developed on their contacting surface. And that friction force is enough to resist the movement of this calculator even if I push it on a certain magnitude. But if I increase the magnitude on a certain value, then it will move. Okay, so that is now a different case. Now, for the static case, even if external forces are applied to the object, if it will not move, then that means the actual frictional force is less than F maximum. Now, F maximum again is mu s times n. Okay? Next. So, yun lang ang dapat nyong tandaan, na pag ang actual friction force ay less than or equal sa F maximum, it is still in the static case. But, let's proceed. There is what you call impending sliding. Okay? The meaning of impending sliding is if the actual friction force is just rightly equal to the maximum friction force. Okay? So, pag saktong-sakto that the actual friction force is equal to F max, then there is impending sliding. Ano ba yung meaning ng impending? What is the meaning of impending? When you say impending, in other words, it's on the verge. Okay, on the verge. And impending sliding, meaning it's on the verge of sliding. Ano ibig sabihin nun? For example, itong calculator. I will slightly increase my pushing force from 0 to a certain magnitude. For example, I will slightly increase and in such a way that I reach a point wherein for a very slight increase from that certain magnitude, it will already move. So when you say if it's on the verge of sliding, then it means that konting na lang na increase, very small amount of increase on the external force, it will cause the object to move. Okay? Now, the last case is dynamic case. This is now when there is already movement on the system. Okay? So, for example, ito, if this now moves, then it's now on a dynamic case. Dynamic case is when, okay, what happens if the case is dynamic is when initially we assume it to be static and we solve for the actual friction force. Now, if it happens to be greater than F maximum, which is equal to mu s times n, then therefore, this value is no longer existing. Rather, okay, this means that it is in the dynamic case, and that if it is in the dynamic case, actual friction force is now equal to kinetic friction force, or that is equal to coefficient of kinetic friction times normal force. It now becomes constant, okay, when it is on the dynamic case. So, the difference between static coefficient of friction, this is what you will use if it's still on static case, but if it's already on the dynamic case, then the friction force is constant of this equation, using this equation. So, in static case, coefficient of friction is also static, but in the dynamic case, coefficient of friction is also dynamic, meaning for static and dynamic case, the coefficient of friction is not equal. Kasi once the object is already on the movement, friction force or the roughness of the surface has a lesser credibility or has a lesser resistance because there is already movement. So the roughness, the efficiency of the roughness lessens. Okay, so let us now proceed to an example so that we could further understand the concept involving dry friction. Okay, here we have a 100-pound block, okay, and it's initially at rest on a horizontal plane. So this is the horizontal plane. Determine the friction force between the block and the surface after P was gradually increased from 0 to 30 pounds. So there is a pulling force P right here, and the magnitude of P is increased from 0 to 30 pounds. Now, it is given that on the contact surface, mu s is equal to 0.5 Let me just clarify this. Okay. Okay, sorry if it's not really that clear. Okay. Now, mu s, or static coefficient of friction, is 0.5 and kinetic coefficient of friction is 0.2. Now we are to determine the magnitude of P that would cause impending sliding to the right. Remember, pag sinabi nating impending sliding, actual friction force is equal to maximum static friction. But we have to first determine the friction force. Okay. Etong mangyayari, this is what will happen. Okay. So it is given that the weight of the block is 100 pounds. This is already the weight. It's not a mass, so we don't have to multiply it to gravitational acceleration. Okay. So always on the, if you're going to consider the FBD of the block, so you have, of course, its own weight, and then the normal force on the plane of contact, okay, which is perpendicular to the plane of contact. We have the normal force, and if there is a pulling force P on this direction, then the developed friction force on the plane of contact will be opposing the possible movement. Okay, now, it is said in the problem that this is increased from 0 to 30 pounds gradually. Okay, so in this diagram, it's so easy for us to get the normal force. We just sum up forces vertically, and obviously normal force is equal to the weight of the block itself, which is 100 pounds. So that once we are able to get the normal force, it would be easy for us to get the maximum static friction, and that is mu s times the normal force. So given in the problem that mu s is 0.5, so we'll have 0.5 times 100, and that will be 50 pounds. Okay, so that the maximum static friction is only 50 pounds. Okay, now in the actual scenario here, the maximum value of P would be 30 pounds. Let's see, okay, if the friction force developed due to this force exceeds F maximum. So if we are to sum up forces horizontally, okay, assuming that it is static, then P would be equal to the friction force. So if P is on its maximum value, which is 30 pounds, then friction force developed is also 30 pounds. Now, assuming that this is static, our friction force is simply equal to the force P applied. So in this case, if P, whatever the value is, the value of P is, that's also the value of the friction force in this diagram. Okay, so that from 0 to 30 pounds, okay, if P is 30 pounds, then friction force is also 30 pounds. Now, if we compare that to the maximum static friction, as you can see, the maximum static friction is less than, or, no, is greater than the actual friction force. Now, this friction force is accepted since we have proven that it is actually static by concept, that when we compare that to F maximum, it is less than F maximum. So therefore, if we look at our previous slide, okay, if actual friction force is less than F maximum, okay, then it is on static case. So even if we increase P from 0 to 30 until 30 pounds, no, the system is still in static case or static equilibrium. Okay, letter B. So that's the answer for letter A. Okay, determine the friction force. So friction force depends on P. So if P is on the maximum magnitude of 30 pounds, then FF is also 30 pounds. So from 0 to 30 pounds, value of P, it is still in static equilibrium. Okay, and FF is simply equal to P. Okay, because when we compare that to F maximum, which is 50 pounds, okay, it is greater than the actual friction force FF. Okay, next, determine the magnitude of P that would cause impending sliding. So the friction force that would cause impending sliding is when FF, friction force, is equal to F maximum. Okay, so that if FF is equal to F max, which is equal to 50, and we know that on this figure or system, P is simply equal to FF. Okay, so that if FF is just equal to the maximum F, making it produce an impending sliding, then P would also be equal to FF, which is also 50 pounds. Therefore, the magnitude of P that would cause impending sliding is 50 pounds because it makes the actual friction force just equal to F maximum. Okay, next. So, before we proceed to the next problem, this is the concept. This is how you analyze whether the body is on static case, on impending case, or dynamic case. First is you have to assume that the system is equilibrium. Okay? Next, with this assumption, you solve for actual value of the friction force. We could use summation of force Y. Usually we use this to get the normal force, and then we use summation of X or summation of forces horizontal. This is the time when we solve for the actual friction force. Now, we also solve for F maximum, which is equal to mu S, or the coefficient of static friction, times the solved normal force here. Now, compare. Okay, we will compare actual friction force, okay, during assumption that it is static. Okay, compare actual FF and F maximum. Now, what happens is, if the actual FF is less than F maximum, then it is static. If FF is equal to F maximum, then the sliding is impending, meaning it's already on the verge of sliding. But if FF is greater than F maximum, then it is already dynamic, and we have to resolve friction force. So if this is the case, after we assume that it is a static equilibrium, okay, the values you got here, both the FF during static assumption and the F maximum, is no longer accepted, but rather the actual FF during the dynamic case is already equal to kinetic frictional force, which is equal to mu K, or coefficient of kinetic friction, times normal force. So this is now the accepted value of friction force, constant value of friction force during dynamic case. Okay, let's proceed. Now, for this next problem, we will determine the maximum force P that can be applied to block A in the figure 8 without causing either block to move. So we will now determine what is the maximum value of P in which both block A, so this is block A, and this is block B, maximum value of P wherein both of them will not move. So how do we do that? Since there are two blocks and there's one surface, as you can see here, there are two contact surfaces. The contact between the blocks A and B, and the contact of block B to the horizontal surface. Now, it is also indicated in this problem that in this contact between block A and B, the mu s is 0.2, okay, and the contact between block B and the horizontal surface has a mu s of 0.1, okay. So what we have to consider are the two possible frictional forces developed. First one is the friction force developed in this contact surface, and next one is the friction force developed on this contact surface. Now we will consider the first contact surface. On the first contact surface is block A. We will consider block A, and we have here force P. Okay, this is block A, and it has a weight of 100 pounds. Now, since we consider block A, okay, on the contact surface between block A and block B, which is this contact surface right here, it has developed normal force, which is of course perpendicular to the plane of contact, and friction force. Now, friction force always opposes the possible movement. So if we are going to apply P on this direction, then the possible movement is also on that direction. So friction force against this block A would be opposing the possible movement of block A. So the friction force is on this direction. Now, since there are two contact surfaces, we consider this first surface, so we'll name this normal force NF1 and friction force 1. So it is clear that using this equilibrium equation, normal force 1 is simply equal to the weight of block A, which is 100 pounds. Now that makes maximum static friction mu s times NF1. Okay, so we have F max 1. So our mu s on surface 1 is 0.2. It's given in the problem, 0.2 times 100. That will be 20 pounds. Okay, now the maximum value of P to make A still on static case is when it is impending. So to make this impending, FF1 will be equated to F max 1. Okay, now using summation of force horizontal, our P is simply equal to friction force. But if we will equate the friction force to maximum force, then friction force will be 20 pounds, which makes the P 20 pounds. Meaning, the maximum force P that will remain block A to be static is 20 pounds. No? So this is max P to remain block A static. So, okay. So if it's impending, it is still static because basically it's not yet moving. So the maximum value of P, so if we will apply 20 pounds or less, block A will not move. Okay, but if you will apply a force of above 20 pounds, then block A will move. But the question here is maximum force, wherein both blocks A and B will not move. Okay, we now know what value of P, maximum value of P to remain block A static. Next is we will consider block B. So for block B, okay, now on block A, the normal force 1 is upward. So on block B, normal force will now be downward, and that is normal force 1, which is equal to 100 pounds as solved on this FBD. Okay, again, we are now on FBD of block B. Okay, since friction force on FF1 on block A is to the left, then therefore on block B, it is now to the right. That is FF1, and that is equal to 20 pounds. Okay, now on this second surface of contact, there is another normal force, okay, which is NF2, and kasi what will happen is there is also a possibility na pag mag-apply tayo ng force P dito, possible na siya lang ang magalaw, yung block A lang ang magalaw, yung B retain lang dito sa kanyang position. Pero meron ding possibility na if malakas ang roughness dito or depende sa kapit dito na surface, both sila gagalaw. Okay? So alam na natin kung anong P, maximum P to make A remain static. Pero hindi natin alam what value of P will remain block B static. Now, ito mali pala to. We have to use FF1 equals P because we are looking for maximum P. Okay? Yan. So, dito sa second contact surface, there is also another FF na naman na form. Okay? So, this normal force and friction force is in between this plane of contact. Okay. So, obviously, we sum up force vertically. NF2 is simply equal to NF1. And the weight of block B, of course, meron ding weight ang block B. It is given to be 200 pounds. So, weight ng block B is 200 pounds. So, dalawa sila. Okay, weight of block B. So, that will be 100 plus 200. That will be 300 pounds. Now, F maximum, second friction force maximum, okay, F max 2 is for this second surface. So, we'll have mu S. Mu S for second surface is 0.1 as given in the problem. 0.1. And then NF2 is 300. Okay. Ayan. That will be 30 pounds. So, the maximum P to retain B as static is when the friction force between B and the horizontal surface is of maximum static friction, which is again equal to 30 pounds. Okay, so that if we will now sum up forces X, okay, P will be equal to FF1 or P will be equal to FF2 or that is F max 2, 30. So therefore, this is max value of P to remain block B at rest or static. Okay, so ganito siya. There are two values of P, but what we are looking for is only one maximum force P, wherein both the two blocks will not move. So, if we will study the two, this is the maximum force wherein block A will not move, which is 20 pounds. Meaning, if we apply a value of P greater than 20 pounds, block A will already move. Now, for block B, the maximum value of P which retains B at rest or static is 30 pounds. Okay? Therefore, which of the two values of P will make both of them static? And that is, of course, this value. Okay, imagine, if P is only 20 pounds, of course, block A will not move because 20 pounds is the maximum P where A is still static. Then, block B will also not move. Kasi yung maximum force P which makes B move or still static is 30 pounds. Therefore, less than 30 pounds, it will not move. Okay? So, if P is 20 pounds, both A and B will not move. Kasi, if P is 30 pounds, A will definitely move. Bakit? Kasi yung maximum P lang para hindi siya mag-move is only 20 pounds. So, if you will apply 30 pounds na force P in this system, then A will move even if B will not move. But the question asks us which force P, maximum force P, wherein both of them will not move. Syempre, the answer will be only 20 pounds. Okay? Max value of P where both blocks A and B are still at rest. Yan siya. So, yun ang kanyang concept ng dry friction. Okay. Let's have another example tayo. Ito. Okay. Let's have this one. Okay. Can the system in figure A be in static equilibrium? In the position shown, the uniform bar A weighs 500 pounds and the weight of block C is 300 pounds. Friction A is negligible and the coefficient of static friction is 0.4 at the other two contact surfaces. Okay, ganito siya. Yan. Merong bar AB, nakapatong siya dito na surface and on block C. Ngayon, the question asks us if this remains static, meaning both of the objects will not move. So, we have to determine or compare values of friction forces. Now, remember, okay, given lahat ng weight of AB, bar AB, and of block C. Given then, it's also said here that friction at A is negligible. So, meaning, dito banda na contact surface is frictionless. So, the only force that acts on bar AB at this contact is the normal force. And this normal force is, of course, perpendicular to the plane of contact. So, let's say we name that as normal force A. Okay. Ganito siya. We will solve this individually. Bakit? What's the possible thing that might happen? What would possibly make this system dynamic is due to the weight of this bar AB. Okay? Due to the weight, it could either slide or it will not slide. It will remain contact here, but block C will slide. So, depende lang sa friction force doon sa plane of contact. Okay. Now, we will have FBD of block AB. This one. So, again, given ang kanyang weight, and that will be 500 pounds. Block AB. Now, dun sa point A niya, only normal, we have normal force only. Again, no friction force on this point of contact because it was said that friction at A is negligible. Okay, so if this surface is 50 pounds, then therefore normal force being perpendicular to this 50-degree incline, this normal force is also 50 degrees with respect to vertical. This one. Okay? Next, dito. dito na contact surface. Okay? At point B. So, the normal force, this one. So, this is the plane of contact. So, normal force is perpendicular. Let's say NB. Tapos, due to the weight of this bar, there is a possibility that the movement of this end is to the right. So, that friction force will oppose that movement to the left rather. So, friction force will be to the right. Yan. Okay? Kasi, dahil sa weight nito, pwede siyang matulak to the left. So, yung friction force niya is against the movement. So, to the right yung friction force sa B. Okay. Now, okay, we will initially assume that bar AB is static. Assumption pa lang ito ha. Kasi yun ang unang step. So, with that assumption, we will solve for friction force here. Okay. How do we do that? Siguro, we will have to use the three equilibrium equations. Why? Because as you can see in this free body diagram, there are two unknowns. We have NA, we have FB, and we have NB. So we really need three equations. Now, I think it would be best to use this. And we will sum up moment at point B because it will help us solve for the normal force at A. So, I think it would be easier to break this down into two components. We have NAY, NAX. Okay, again this is 50 degrees. Okay, so we need to get the horizontal, the perpendicular distance of NAY on B. That will be, since this is 10 feet, the whole bar is 10 feet as shown in the problem. Okay, so, and also, bar AB is 30 degrees, lying 30 degrees with respect to horizontal. So, therefore, this perpendicular distance of NAY is 10 cosine 30. Now, for NAX, the perpendicular distance about B would be 10 sine 30. Trigonometry. Okay. So, at moment at B, our 500 pounds will have perpendicular distance about B of only 5 cosine 30. Kasi half lang siya. 5 feet lang dito, half. 10 feet whole bar AB. Okay, so 500 perpendicular distance to B is 5 cosine 30. So that's the moment about B. And then we'll have minus NAY. NAY is NA cosine of 50. As you can see in the figure. Then negative because it is counterclockwise to B. Then this perpendicular distance is 10 cosine 30. Next, minus NAX and NAX. Sorry, dito na lang. NAX is NA sine 50. And perpendicular distance is 10 sine of 30. Now, everything, we equate it to 0. So, therefore, we'll be able to solve for NA. That will be 500, 5 cosine 30. Make sure that it is on the degree mode. Minus NA here will be variable X cosine 50. 10 times 10 cosine 30. Next is minus NA or X sine of 50. Then perpendicular distance 10 sine of 30. Then equals 0. Everything is equal to 0. So let's see what's the value of normal force at point A. we'll have to 30.4. That is, of course, in pounds because it's normal force. Okay, that being said, we could now solve for NB. So to solve for NB, we'll use sum of forces vertically. Okay, NB, upward. Okay, upward equals downward. Upward forces NB, downward forces, we have the 500-pound weight of the bar AB. And NAY, since yung NAY is also upward, dito na side, positive siya. So, dito na side, negative na siya. So, minus NAY. So, NB equals 500. NA natin is 230.4 minus 230.4 cosine of 50. So, NB would be equal to 500 minus 240, rather, minus 230.4 cosine of 50. Okay. That is 351.9 pounds. Okay. Now, yung maximum friction, static friction force at point B, that would be mu S times NB. Ano yung mu S dito na contact surface? Tingnan natin. It is said here that coefficient of static friction is 0.4. Both two contact surfaces, dito at saka dito, 0.4. So, we have 0.4, then 351.9. Okay. 0.4 times 351.9. Okay. 140.76. Okay, we are still computing Fmax on contact B. Now, we will compute actual FB if this is static. Okay, actual. So, we'll use sum of forces horizontally. Okay, rightward forces positive. So, FB is positive to the right. Ano pa? Is there other? Okay, we have NAX. Okay, so NAX, that's equal to NAX, or that's NA, which is 230.4, and NAX is NA sine of 50. Okay, 176.5 pounds. Okay, we will now compare the actual value if the system is static, and this is the maximum. Dito pala. Let's compare. Saan mas malaki? Yung actual kaysa sa maximum. Ngayon, yung actual mas malaki sa maximum. What's the meaning of this? Meaning that it is on dynamic. It's no longer static. Kasi yung static, if yung actual is less than or equal sa maximum. Ngayon, ang nangyari yung actual, mas malaki kaysa sa maximum. So, it is dynamic. And since it is dynamic, the actual friction force will be resolved, and that will be kinetic coefficient of friction times the normal force doon sa contact surface sa B. So, both of them are obsolete kasi we found out that it is actually dynamic case. So, this is now the actual value of friction force. Now, it doesn't ask for the actual friction force. What it is asking is, can the system be in static equilibrium? Now, the only way this system becomes static is if no movement is produced. Now, with the FBD on bar AB, we have found out that it is dynamic, meaning due to its weight, it could possibly move. And whether or not block C will move, we found out that bar A moves, therefore, automatic, it is not static. Okay? So, with this only question in this problem, we don't have to determine whether or not block C is also moving or not. Okay? So, That's it.